Hi, in this problem we're going to find the focus and the directrix of a parabola given the a, which is the leading coefficient, the p, which is the distance between the vertex and the focus or the directrix, and the b, which is the vertex of the parabola, denoted by the letters h and k. Now, before we actually find what's the focus and the directrix, I just want to quickly explain what do you mean by these words focus and directrix. So if you can think about a circle, we know a circle has two key points, two key parts to it. One is the center and one is a radius. A point called the center and a line called the radius are major parts that define any circle, right? So every circle is the same distance away from a point called the center, and that same distance is the line radius. So just like how this point and this line is really important to the definition of a circle, when you have a parabola, there are two parts to a parabola that are really important to the definition of a parabola. So a parabola also has a point and a line that is really important to it. The point is called focus, which is always inside the parabola. The point is called the focus, always inside the parabola. And the line is called directrix, which is always outside the parabola. And in such a way that the distance, this middle point is called the vertex. The distance between these two, if you call it to be p, will be the same from the focus to the vertex as well as from the vertex to the directrix. So these two distances will be the same. Same thing if it's a parabola facing down. If it's a parabola that's facing down, the two key points, the focus, which is the focus, and the directrix will be, the focus will be inside because the parabola is facing down, and the directrix will go up. They flip, that's all. And the parabola flips, the focus and the directrix also changes the positions. So you can just compare it with the definition of a circle, just like how the center and the radius are two key factors to the definition of the circle. Just like that, you can think about the focus and the directrix as two main parts to the definition of a parabola. And why are these two things important? Because no matter which point we pick on this parabola, it will be the same distance away from this point called the focus and the line called the directrix. Okay, so really very quickly to show you an interactive graph for it. Here you can see a parabola is here, the point P, that's your vertex right there. There's the focus and the directrix. See how the distance from the vertex, the distance to the focus and the distance to the directrix is the same. Now if I move it somewhere else, another point on the parabola, P stands for a point on the parabola here in this graph. So if I try to pick another point, it's still the same. No matter where I move it, that distance between the focus and the point and the directrix, that remains the same. Okay, so no matter where I pull it, they both have the same distance. I'm going to go this way. Look at that. This distance PF is the same as this distance P to the line or the directrix. So how do we find this focus and directrix? In order to find it, we have to bring it to the vertex point. The vertex helps us figure this out, find out focus and directrix. So how to do that? Let's think about a graph like this. We know that the vertex point is on the parabola and it's right in the middle over there. It's denoted by the letters H and K. And P points above it is the focus and P points below it is the directrix. So since the vertex and the focus are on the same line, which is the axis of symmetry, this is our axis of symmetry. So since they're both on the same straight line, they will share the x-coordinate. They will both have h as the x-coordinate. And since the focus is P points above the vertex, on the y-coordinate with the k, you're adding the p. That's how this became k plus p. And since the directrix is P points below the vertex, the equation of the directrix becomes y equal to k minus p. So if you really think about it on a problem, this is how it's going to show up as. So they have to give you a, which is a leading coefficient. So let's say I gave you that a is going to be positive. or some positive number. A is positive. I just want to know that my parabola is facing up. And I gave you the distance between the focus and the vertex to be 3. And I gave you the vertex to be 1, 1. Okay? So in this problem, how can we find out the focus and how can we find out the directrix? These are the two questions. So I'm going to write the formula for the focus, which is h comma k plus p. And the formula for the directrix is y equals k minus p. Alright? So all we have to do is, we have to know what's h and k. That we get from the vertex. And we have to know what's p. All you have to do is plug in these points here. So the focus is, instead of h, I can plug in the number 1. And the y-coordinate is k plus p. I know my k is 1 and my p is 3. So I add them, 1 plus 3, I get 4. So that's my focus. And my directrix is y equals k minus p. I have k is 1 and I have p is 3. So 1 minus 3, my answer is negative 2. So y equals negative 2 is my directrix. So if you think about this, another example where a is negative. Let's talk about when a is negative, what will happen. So we have our graph, and since a is negative, our parabola will face down. So our focus will be inside and our directrix will be above. Their places will get switched. So the only difference here is that the focus instead of being h and k plus p, because it is k points below from the vertex, it will be k minus p. And the directrix, instead of being k minus p, it will become k plus p because it is above the vertex. So that's the only difference. So let's say we are doing another example. Example number 2. I gave you a is negative 5. So we know that a is a negative number, so this parabola faces down. This just tells you that the parabola faces down. And p will be given to you, let's say p is 7, and the vertex was given to you, let's say it is 2, 3. So these 3 items will be given to you. You have to find the focus and you have to find the directrix. So to find the focus, I write the formula for the focus as h comma k minus p, because the parabola is facing down. And the equation for my directrix is y equals to k plus p. Now because the directrix is above the vertex, right? The vertex is my hk. So all I have to do is plug in the numbers. Instead of h, this is my h and this is my k. So my h is 2, k minus p, p is 7. So 3 minus 7, it's negative 4. So that's my focus. And my directrix is y equals k plus p. K is 3, p is 7, 3 plus 7, we get 10. Y equals 10 is the line, which is my directrix for this problem. So to sum up, all we have to do is this. Let me go to my first screen that we had. All we have to do is remember that when a is positive, the parabola faces up and my focus is inside and my directrix is below it. And when a is negative, my parabola faces down and my focus is still inside the parabola, so it goes down and my directrix is above. Okay, so here the formula for the focus is h comma k plus p, because it is above the vertex. From the vertex it's above. And the formula for the directrix, is y equals k minus p, because it is below the vertex. And this will switch when it comes to when a is negative. So you get h k minus p and y equals k plus p. And the two examples for I have done one example for each case over here.